Please, now, a great round of applause for Mr. Coder.
Thank you, thank you. All right, folks, how we doing today? All right, good to see you, good to see you. Okay, I would like to tell you that this is being filmed in front of a live studio audience for the second time in my career. So let's go ahead and take a look at how we are going to calculate rate law. Okay, now here's the situation with this. What we're going to do is we've got these reactants, okay? And these reactants are going to react to form a product. And we know that the rate of that reaction is going to go so fast, okay? The question now is how fast will it go? Is that something that we can measure? Can we measure the speed of that reaction? The answer is yes, if we use this formula, okay? The rate of formation of product AB, okay, if this is our reaction, A plus B yields AB, okay, the rate of formation of product AB is going to equal K times the concentration of A to the X power times the concentration of B to the Y power. Okay, what does all this mean? K is our rate constant. It's only going to change with the temperature. Okay, you're going to have the same K value for every single problem as long as the temperature remains constant. Okay, and the units are this. Okay, it's this crazy looking weird formula, which is this unit for K. Okay, the unit is time to the -1. Now, what do I mean by time? I mean, are we talking about seconds? Are we talking about minutes, hours, days, years, whatever, okay? The time, let's say we're dealing with seconds. So you're going to write, so you would write literally seconds to the, notice how it says -1, seconds to the -1 times the molarity to the negative overall order -1. What's an overall order? That's what we're going to talk about next, okay? The orders tell us how the rate will change with the change in concentration, okay? So this X and this Y up here, these are my orders, okay? X and Y are my orders. The things inside the brackets, remember, brackets refer to the concentration of something, okay? So A is going to be one of our reactants, and since it's inside the brackets, it's the concentration of A. B is the same thing, concentration of reactant B. X and Y are called our orders, and depending on what the order is, that's going to change how fast the reaction will go if we double the concentration of our reactants, okay? The overall order is basically you just take your orders and you add them up, okay? So if X is 2, meaning that it's second order with respect to A, and Y is 3, meaning it's third order with respect to B, what that means is that we are going to have an overall order of 5, okay? So this is the rate of AB equals K, which is our rate constant, times the concentration of A to the 2, times the concentration of B to the 3. So 2 is the order of concentration A, 3 is the concentration, or the order of concentration B. You add those up for an overall order of 5. Now, we're going to play with all that. All of that's going to mean more to us when we start calculating the rate law. So let's go ahead and take a look at a few other things. So what do these orders mean? Now, it is possible to have a zero order reaction. What that means is that if you double the concentration in a zero order situation, doubling the concentration is going to do absolutely nothing to the rate of the reaction. The rate of the reaction is going to remain constant no matter what you do to the concentration of A, okay? That's a zero order reaction. If it's first order, that means that whatever you do to the concentration of reactant A is pretty much going to have the same effect on the rate of the reaction, okay? If you double the concentration of A, you're going to double the speed of the reaction, okay? So it's like almost like a one-to-one sort of situation, okay? You double the concentration, you double the rate of the reaction. Now, second and third order is where it really starts to speed up, okay? If you have a second order situation in regards to A, that means when you double the concentration of A. So maybe you have a 2 molar concentration of hydrochloric acid, okay? And now you double that concentration to 4 molar. Instead of making the rate of the reaction just double, you're going to quadruple the rate of the reaction, Okay, so if you double the concentration of A, you increase the rate of the reaction by 4 times. Lastly, if A is third order, then when you double the concentration, you're going to make the rate go 8 times as fast. Okay, now this down here, I'm sorry it's already filled in for you. I know you're devastated. This gives you a rate of a reaction right here. Okay, so here's your formula. It says the rate equals K times A squared times B cubed. How much more quickly would the reaction proceed if? Okay, so if we double A, then since A is second order, I know that my reaction is going to go 4 times as fast. Well, what if we triple B? Okay, what if the concentration of B is tripled? If I triple the concentration of B, then that's going to make this go 27 times. It's going to increase the rate of reaction 27 times. The reason for that is because 3 cubed is 27. Okay, so if you do 3 cubed, that number is 27. Now, what happens if A and B are both doubled? Okay, well, if you double the concentration of A, then it's going to make it go 4 times as fast. And if you double the concentration of B, then that's going to make it go 8 times as fast. And 8 times 4 is 32. And so that means that it's going to go 32 times as fast. Now, if you would like to get a brief idea of how a rate law problem works, we're going to take a look at that in the next video. However, there are steps right here. You can read over these steps if you want. I could read them to you, but I guarantee that you're going to be asleep by the time that I finish reading them to you. I don't know, you want to try it? To find the order of A, find 2 trials, experiments, where A yeah, you're asleep already. All right, so yeah, you can write all this down if you want to. You can pause the video and get all that written down, blah, 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 blah. Or you can just wait for the second video where I am going to work a rate law problem with you. That, my friends, is going to be where you're going to get the most help in figuring out how to do a rate law problem. And that, my friends, is how it's done.